already. First stuff is review. We've done it already, but I do want to take you through a problem because no one asked about one on the homework, and that is all about the symmetry. So if we're testing, you've seen these slides before, they were earlier in the year, but I do want to skip those and go right to the examples to show you what they look like. Okay. So let's cheat first in part A. Is A an even or an odd function, or neither? Say again? Even. Why?
Because the exponent.
What's the exponent over here? What's that?
1?
No. Is there an exponent there?
No.
Technically speaking, there is. That's x to the 0. Is 0 even or odd? It's even. No, it's even. Yeah. Because it's even, then we know that this function is going to be even, and we know where we're going. Okay, let's jump down here. Even or odd? Odd. Okay, so now we know what kind of answers to expect. Now, to test that, you need to plug in negative x for x, see if it matches. Plug negative y in for y, see if it matches. Plug them both in, excuse me, and see if they match. So we don't need this guy anymore. Get rid of that. All right, so y is equal to 2 times negative x quantity squared minus 3, which gives me y equals 2x squared minus 3. That matches. We're good to go. Any problems? Lovely. If we check the other one, negative y is equal to 2x squared minus 3. So y is equal to negative 2x plus 3. Doesn't match. Not symmetric. And then the last one is doing both of them. Negative y equals 2 times negative x quantity squared minus 3, which means that negative y is equal to 2x squared minus 3, so y is equal to negative 2x squared plus 3. Doesn't match. And that's testing all 3 scenarios. Same would be true in part B. Plug in negative x. Notice the difference here is that when you take negative x and you raise it to an even power, it becomes x squared. But if I take negative x and I raise it to the 3rd power, what's that equal to? Odd power keeps the minus sign. That might prove helpful when working with the odd functions. We didn't do composite functions yesterday, did we?
No.
No. Okay, so we'll do them now. Composite functions, putting one function into the other. Actually, we're going to do that soon. Composite functions. These are all the other combination things. Okay. Add the functions together. You've done that. Add, subtract, multiply, and divide. No problem. That shouldn't be easy. But composite functions usually require a little bit of review, which looks something like this. So you'll recall the notation here. F of g of x is the same thing as this. Don't get that confused with the opposite, g of f of x. Let's talk about this. What goes into what? Do you put f into g or g into f? Good, g into f. So take the function of g and put it into f. Nice little illustration there showing what happens with the x. It goes into the first function, it spits out an output. That output then goes into f and you get your final answer. So calculate those two. What's f of g and what's g of f? Lana, what's f of g?
It's 2 times cosine of x minus 3.
Perfect. And what's g of f?
It's cosine of 2x minus 3.
Good. Okay. Any problems? Pretty easy, yes? Obviously, if the function can be simplified, if you're squaring things, you want to multiply it out and simplify it. Those can't really be simplified. We're done. But you knew this already, right? Mm-hmm. The thing that I think is going to require a little bit of review is this guy, polynomial inequalities. I know you've done them. They can be a little tricky, so I wanted to work through one with you because it has a relevance to what we're going to be doing later in calculus. Does that second phrase make any sense to you? Do you know the term Boolean logic? No? Does it make any sense if I was to say to you, you plug something in your calculator and it gives you a 0 or a 1? You saw that before? Okay, well, I'll review it just to make sure we're all on the same page. But it's a nice handy tool that you can use to save yourself some work. Okay, so let's start with this guy. I'm looking for all the values that when I plug it into x, I get x squared minus 10 greater than 3x. Okay, so what I'm going to do first is the following. Just like you would solve an equation, set it equal to 0. Sorry, set it greater than 0. Then I'm going to set it equal to 0. And as you get better at these, or if you already know how to do these, you can probably skip some of these steps. Okay so far? Cn, anybody know what that stands for? Those are critical numbers. Those are a big deal. So something weird happens at -2 and 5. What happens is that the function is equal, not necessarily greater than. So what we're going to do now is slap those on a number line. Does this sound familiar now? Is it coming back to you? Beautiful. When you put them on a number line, please put them in the correct numerical order. -2 here, 5 here. It doesn't have to be exact. Solid dot or open circle on -2.
Open.
How do you know it's open?
Because it's not clear.
Beautiful. On 5, solid dot or open circle? Open. Now I would suggest you go through those points individually and not lump them into one sum. Now you test regions. What's a good point to pick over here? Or what is a point you can pick over here? -3 is just fine. -10, -gabillion. It doesn't matter as long as you're to the left of -2. So let's put in -3. If I put in -3, do I get a true statement? -3 squared is 9. Plus 9 is 18. Minus 10 is greater than 0. We're good to go. It's a true statement. What's a really good number to pick in here?
0.
0 would be great. If I plug in 0 there, 0 minus 0, 0 minus 10 is -10. -10 is not greater than 0. That doesn't work. And then over here, what do you want? 10? 10 sounds great. 10 squared is 100. Minus 30 is 70. Minus 10 is 60. All we care about is that it's positive and we're done. So those regions are where the inequality is true. Express that in interval notation. What is this in interval notation? Parentheses or bracket?
Parentheses.
Union.
Parentheses 5.
Well done. Perfect. Okay. All right, bust out your calculators. This is a problem that's not too bad to do by hand, but we're going to get to some uglier problems. And there's a couple different ways that you can do this. The following thing I'm going to show you is called Boolean logic. So what you're going to do is, we're going to start by doing this region over here where we talked about, what did we choose? -3, I think? We're going to test -3. So what you need to do first is store -3 into the calculator. So -3 stow, and then put it into x. when we're doing this, you might be saying to yourself, why am I going through this hassle when I can just plug -3 into the equation? You may not necessarily use this. I'm just giving you another tool. When the problems get more ugly, when the problems get uglier, more ugly? Uglier. Uglier? We'll go with it. Okay, who cares? That's why I went into math. The calculator will do this for you. Okay, so now go to the home screen. You should still be on the home screen, right? Okay, type this in. That whole line just as it appears. So x squared minus 3x minus 10 is greater than. You'll find the greater than under the math symbol. So math test. Math.
Oh.
And then test. Is it math test? Is that what you did? Yeah. Yep, second math. Sorry. It's above the math button. I said it backwards. It's test above the math button. Once you have this on the screen, hit enter. It's only ever going to give you one output. It's going to either give you 1 and 0. That's it. 1 means true. 0 means false. So you should all have a 1 on your screen, yes? Okay, good. You've done all the hard work. Checking other regions is really simple now. So all you need to do is pick a number over here. I believe we use 0. So do 0 store x again. And then instead of typing in that whole thing, you can just, depending on the level of your calculator, you can either scroll up to it, or you can use the second enter trick. I think all of you at this stage should be able to just go up on the calculator using the up arrow. Hit enter, enter again. It should put out 0, because that's false. And then go through the process again. So the nice thing about the Boolean logic is you only have to type that into the home screen once. And then you can just keep testing numbers and regions over and over and over again. Would I use it in this problem? No, because I only have to test 3 regions and I'm pretty good with those numbers. But as the number of regions increases or the equation becomes more complicated, I definitely want to have another tool at my disposal. Does this all look familiar? Have you ever seen that trick before? Okay, so now you've got an option there. Oh look, I did all the work. Okay, now things get a little uglier here. The process that I took you through on the last problem also applies here, but we need another twist here. What else do I need to know about this problem?
Center equal to.
Good. So we're going to have some solid dots instead of some open circles. What else? Forget about the polynomial thing. What can't x be?
X can't be 5 or 3 or -3 seconds, right?
Correct. So I'm going to put a note of that up here. X cannot be 5 or -3, whoops, -3 halves. Why, Michael?
Because it's in the denominator.
Good. And again, no 0 denominators, no negative square roots. Those will be open circles. Regardless of what happens in the rest of the problem, these are always open circles. So I'm going to add those as critical numbers to the problem. From this point on, you solve it the same way we did before. Turn it into an equal sign. How do I solve that? Cross multiply. Did I do that right? I think so. Now I've got 3 critical numbers. Gets a little tricky here because I have to remember the -8 is going to be a solid dot. The other 2 are going to be open circles. And that's why I said it's easier to go, or it's a better idea to go through this independently. So -8 is the furthest most to the left. Then I've got a -3 halves. And then I've got a 5. then we need to test some regions. This is a problem where I would probably use my calculator. Store a number like -10, type that ugliness into the calculator. By the way, when you type it into the calculator, you've got to be sure to put parentheses around these, and then see if it spits out a 0 or a 1. Common mistake that people make with these types of problems is they assume once they have one region that the other regions will just alternate. That's not necessarily the case. Don't forget also solid dot at 8, open circle at -3/2, open circle at 5. If you don't need that, that's great. So if I put in -10, I get 2 over -23, and I'm wondering if that's less than or equal to 2/5. Is that a true statement? Wait, I did my math wrong. -15. Is that a true statement? What do you do if you're not sure?
Check with your calculator.
Yeah, use your calculator to check. If you don't know which one of those is bigger, then use your calculator. Or if it's a true statement. As the denominator of a number gets bigger, what happens to the value of the fraction? It gets smaller, correct. So which of these, number 1 or number 2, which of those is closer to 0? Number 1?
Yep.
1, do you all agree 1 is closer to 0? Okay, so if 1 is closer to 0, is that a true statement? No, it's a false statement. So, false. Doesn't work. What's a good number to pick in here? What's that?
-7.
-7 is great. Okay. Now, if you were using your calculator for this, then all you'd have to do is store -7. You already got the function typed in. You scroll up to the function, hit enter, and it spits out your answer. Then you go over to the next region. Oh, I don't know, a good number in there would always be 0. And then over here, a good number might be something like 10. So, again, this is a problem. If I were doing the problem, I would probably use my calculator on this so that I don't have to spend the valuable time figuring out if 2 -23 is less than or equal to 2 -15s. Okay? Did anybody do the rest of the regions?
Yeah.
What do you got?
So between that.
False?
Yeah, true.
True?
False, true.
So it does just, okay. All right, then interval notation gives me -infinity to -8 bracket, whoops, union, because we're including the -8 there. No, I did that wrong, sorry. We want the true, my bad. -8 bracket to -3/2 parentheses, union, 5 parentheses to infinity parentheses. That time I got it right, correct?
Yeah.
Okay, good. We're all done. Good. If we go back to this mess, whoops, that mess, the calculator is a very useful tool. Remember that you won't have the calculator on the entire test. However, on the AP test, this is a reasonable non-calculator question. This is not a reasonable non-calculator question. They probably won't give you anything that complex without your calculator. Okay. Quiz tomorrow. I will probably give you all period to work on the quiz tomorrow. There is homework tomorrow, but it'll be kind of be on your own. Look at reading a chapter or reading a section, and figuring out the problems. And then, as I said in my Schoology post, the quiz tomorrow covers P1, P2, and trig. This stuff is not on the quiz tomorrow. Okay, we good? Nothing to worry about, just a quiz. What's the worst that could happen?
If you fail it and then they call you home because you have an F in the class.
Yeah?
Yeah.
And then what?
And then your parents yell at
And then what?
you. And then they don't pay for